Well, we can start. Today we will start with a presentation from the BSC, from the Barcelona Supercomputer Center, and also with the rest, was the la Red Española en Supercomputación, because we have to acknowledge them for the funding for the organization of this symposium. Then we have one person of the BSC, that it is Isabel Botey, that she will present the information about the BSC, but in general, the whole network of the Spanish supercomputing. You can start. Thank you very much for coming, and well, thank you very much for the funding for the symposium.
Okay, thank you for your introduction. As said, my name is Isabel. I'm a project officer at the Barcelona Supercomputing Center, and I'm here today to represent the Spanish Supercomputing Network. Let's start with when was the Spanish Supercomputing Network born. The Spanish Supercomputing was established in March 2007 at the initiative of the Ministry of Science and Education. It is a network composed for 14 interconnected nodes connected by high-speed networks. It contains 14 institutions from Spain, but 16 supercomputers and 9 data management centers. As you can see on the map, we are present in Catalonia, Madrid, and Navarra, and so on. And what is the mission of the RES? The mission of the RES is to provide supercomputing resources, data exploitation and artificial intelligence services for the development of innovative technological and scientific projects through our competitive calls. So overall, together, what we offer is a combined capacity of 22 petaflops, which means 22 quadrillion operations per second. We also offer 20 petabyte storage that keep growing with the acquisition of new computers and data centers. We offer more than 800 million CPU hours a year through our calls. ¿Sigo? Okay, we have around 1,000 regular users per year and more than 200 scientific papers annually as well. We are also a member of the Spanish Unique Scientific and Technical Infrastructure Network, which means that we are part of a network of institutions that are dedicated to technological and scientific research. Going to our services, as we said, the RES provides supercomputing, data exploitation, and artificial intelligence services. With the HPC services, users can request computing hours from any of the machines that are part of the RES and access high-performance computing resources. With the data exploitation services, users can use the resources for the exploitation of scientific and technological data using our virtual machines and storage. And for the artificial intelligence services, users can access the hardware and software resources with a high number of GPUs to support the AI projects. These mentioned RES services can be accessed through our access calls. We launch 4 calls during 1 year, 3 for HPC and AI, and 1 for data exploitation. You can submit your application in 3 different deadlines for HPC and AI, which are September, January, and May. And for the data exploitation, there is a deadline of November to February for this year. We also have a new call, which is the AI test, that it's an ongoing open call that I will explain later on as well. So going into detail to each of the calls, first, as I said, we have the access is through the different calls, and we have 3 calls yearly for the HPC and AI resources, and we have around 800 million CPU hours allocated for this call. And the access period is for 4 months, each 4 months, to the resources in HPC in one of the RES machines. Moreover, users can access to specialized support if they have any doubts about using the machine or they find any errors while using it. So why do we say that we have competitive calls? It's because we want to maintain the quality of our resets that we have at the moment, And we also don't have the capacity now to fulfill all the applications that we receive. We receive around 170 activities per call, and we don't have the capacity to fulfill them all. But in this talk, we wanted to highlight that we are actually going to increase the capacity very soon, and we will be able to accept more applications. So feel free to apply because this is a good opportunity. Normally, most of our users are researchers, as some of you, but we also, the calls are also open to SMEs that perform R&D projects. And besides researchers and SMEs, the call is also open for users initiating new European projects or for novel users who have not used HPC before. It is also important to know that we divide our resources in scientific areas that are astronomy, space and earth science, physics, mathematics and engineering, life and health science, homogeneous chemistry, and heterogeneous chemistry and solids. So this is for HPC and AI, 3 calls a year, each 4 months. And since 2020, we also offer the access to the data exploitation resources. Why do we offer this? Because there are scientific groups that have a need to storage large sets of data. They can combine it with computing resources thanks to our offer. As mentioned, we started in 2020 with 1 call per year in this case, and a project range of 200 to 1,000 gigabytes in 3 to 5 years. Last call was in 2022, last year, and 9 projects were selected. In this case, we also offer a specialized support service in case of any trouble with the functioning of the call. As you can see on the image as well, our data storage capacity keeps growing, and we will keep improving the resources of this call. Then we have the AI test call, which is a new call launched this year. This is targeted to small development of AI projects. It's for small access of AI activities. And you can also submit to it through the REST internet, but the application is not so complex as the HPC and AI. So once we have seen who we are and what we offer, I'm going to briefly explain how can you apply and who can apply to these calls. So these calls are for science and innovation projects, and university research groups and public centers from Spain or Europe can apply to it. And the resources are always open only for open investigation. So how can you apply? First, you need to create an account in the intranet and complete an online application form that contains, you need to put the title of your project, you need to choose the scientific area, the type of application. Are we talking about standard, which are the calls that I explained? Are we talking about novel users, European projects, or the small AI projects that I mentioned later? And you also need to describe your project, indicate the software and numerical tools that you use, and describe your team, which needs to contain a leader and team researchers. And if you have any questions, I have put here the email that you can ask any questions there, and we will be happy to give more details about the application process. Then we have the REST Users Committee. We wanted to mention that the purpose of this is to provide advice and feedback to the REST management and coordinators. And the aim is to promote optimal use of high-performance computing facilities by sharing information of the user's experiences and also voice the user's concerns. And you can contact us also through the Spanish Supercomputing Network intranet. Additionally, we wanted to mention that besides the calls that we offer and the services that we offer, we have what we call the REST events. First, we have the users meeting, which is an annual meeting to encourage interactive exchange experiences between coordinators, technicians, and users of the Spanish Supercomputing Network. and it aims to highlight the scientific results obtained thanks to the RES resources. Here we also like to highlight annually the updates of the infrastructures of the RES centers. Last annual meeting was this last week in Barcelona, and next year will be in Malaga. It's open to everyone, and you are all welcome to register and join. Next, we have the scientific seminars. The RES promotes scientific seminars to address technological applications in different scientific areas. An example of a scientific seminar would be today. As a RES, it's part of our mission to be part of these scientific seminars because we want to promote what we do in the Spanish Supercomputing Network. We want to promote what we offer to increase the number of applicants and to increase the quality of the research. And of course, also because we want to support the scientific community, and we think that these events are a good place to share these and exchange knowledge. And as you can see on the screen, these are some of the events that we have sponsored and added as scientific seminars this year. Last, we have the technical training workshops, which are organized by the RES and aim to provide skills for the functioning of the supercomputing facilities. And last workshop was also last week at the annual RES user conference. And last, we wanted to summarize in one slide what the Spanish Supercomputing Network offers. Our main action is to provide access to Spanish supercomputing facilities, but we also provide access to business innovation, to networking and awareness through events, to European supercomputing facilities, to internationalization through the programs, to knowledge and expertise through scientific seminars like this one today, and to training and skills development. So you can please follow us for more info updates on our events, trainings, or calls. And if you have any questions, do not hesitate to contact us on the emails that you can see here or on our website. This is all from my side. Thank you very much.
Thank you very much, Isabel, for the presentation. Do you have any question, comment? Well, I have one. Do you have any news about the new Mare Nostrum 5 when will be available, or they are making the configuration, the setup? Or?
I think Uriel will answer this for me.
Well,
I don't know if we can spoil.
That's a difficult question. We expect it to be ready end of this year, beginning next year. So there is a part that is already up and running on the tests, but these things take time. The other one is still arriving as we speak. Today we have a track with components, and the next call of RES will still work on Mare Nostrum 4, but we expect during this 4-month period to do the transition of projects to the other one. The project is very complex, so we cannot commit on a date, but and you know my boss, he's quite strong on these things. So I could say beginning next year should be already available. And just to mention, we will increase the capacity 30 times. So it's really the perfect moment to apply because at least for 1-2 calls, the competition will be lower.
Because the last deadline for call was last week, I think. Yeah, last week to cover the period since November until February. Yeah. Okay. Then for the next call, the Mare Nostrum 5 will be available in the list of computers and people are. You expect. Well, now is winter, no problem with climatization of the. Okay, thank you very much. Any other comment? If not, I think we can move to the next presentation. The next presentation is, oh, sorry, we can thank again. The next presentation is by Luis Villarejo. He is the CEO of Immersium Studio. His background, he studied computer science in the UPC, then not far from here. Then today he will show us a presentation that the title is Virtual Reality to Improve Soft Skills.
Okay, so good morning, everyone. Thank you for the organizers for the invitation. My name is Luis Villarejo. My background, as has been said in the introduction, is in computer science. I was working at the Open University of Catalonia related to educational technology. And today I come here to explain you a little bit what are we doing from Immersium Studio, which is a spin-off of the Open University of Catalonia, in which we train people, but not in chemistry, not in hard skills, but in soft skills. So to increase people's capacity of empathy, for example, communication, we prepare them for difficult conversations, things like that. So in these 30 minutes, I will try to give you a brief summary of what we have been doing and which are the possibilities of this expertise applied. So we are a team, a multidisciplinary team of pedagogues, technologists, user experience experts, and all together we work to produce or to design and produce experiences, learning experiences, which are impactful and which are the most realistic that we can generate. We have worked in the 5 years since we were founded. We have worked for many different customers like United Nations, the DTI Foundation, for example, for the European Society of Intensive Care Medicine, and Doctors Without Borders, for example. We are producing 2 experiences for them. And we always work in co-creation with the client to generate meaningful experiences, okay? So to improve the capacities of their workers. What we do, 90% of what we do is virtual reality training. And inside that, 90% again of what we do is that we don't use CGI environments. We don't use environments created in which you can see avatars or digitally created environments, but we use 360 degrees videos. And we add interaction inside that. So whenever you use one of our experiences and you use a virtual reality headset, what you see are real scenarios and real people. And then you have to interact with them. It's a kind of learning experience. It's a choose your own adventure kind of learning experience. Okay, so inside of these realistic scenarios, you need to make decisions. And depending on your decisions, some things happen or some other things happen. And then you see the consequences of your decisions. You can go back, make another decision and compare consequences of different decisions. And this way you get exposed to different situations, which you may find in your professional life, and you get experience on them. And whenever you face them in the real life, you go or you make decisions with more confidence because you have already been there, okay? We have received some distinctions, both from the research community and from the industry. And this is the way that most of our experience look like. This is an example from an experience to improve communication and feedback in a corporative environment. And this is the scheme that summarizes how most of our experiences work. Whenever you put on the headset, you play the role of an employee in this particular experience that has been called to an appointment by his manager. And then your manager explains you a problem and you need to make a decision on that problem. And depending on your decision, the story goes one way or another way, okay? The thing is that here, for example, in this experience, you can choose between 3 different types of managers. You can choose between, you don't know Each one of them represents a communicative stereotype. You don't know which one represents which stereotype, but then you choose one, and then you get to be exposed to a situation like that with an assertive manager, an aggressive manager, or with a passive manager. And then we use the figure of a presenter that does the onboarding to the experience to you. It welcomes you to the experience. It explains you which is the context of the experience, which are the goals of the experience. And then once you are completely situated, you start the experience. And then at the end, we use also the figure of the presenter to do debriefings. Whenever we think that there have been meaningful situations on which we think that it pays the price to reflect on, we use the figure of the presenter to reflect on what has just happened. Let me play the video so you can see a video shot of how does this works. So what you will see here is the video shot of a particular person doing the experience. So if the camera moves left or right, is the head of the person who is moving left or right, exploring the scenario. I think that the audio is not working, no? Are we able to enable it? Or is it going to take very long? If not, I can comment on that while we see the video. We have many videos, so if the technician comes, it will go well for the next videos. So I can comment these ones. So here you are in the onboarding part. You can see that you are totally immersed in a realistic scenario. Whenever you look around, you are inside the experience, and this gives you a lot of realism. And here the presenter explains you that you play the role of an employee in a situation in a company, that a problem has arisen and your manager has called you for the appointment. And then the manager explains you the problem, then you need to make a decision, okay? And the decisions comes up in the way of options that you see written on the screen, and then you have to select one of them. This is the part where you select your manager. You don't know which stereotype is behind each manager. And then it comes the part with the manager. This is the assertive manager. So it sits next to you. It explains you things in a constructive way without nerves, blah, blah, blah. So it's a much more easy way to communicate with him and to make decisions. And then you can also compare with different types of managers. Then the story goes on, the situation goes on, and then we expose you to different decision points. During the experience, you need to make different decisions at different points. This is the first one that you find, and you have three options to the questions or the situation that your manager has just explained you. You take the time to read them, and once you have decided, you click on one of them, and then you are exposed to your manager's answer to that option. And then the story goes like that, okay? And this is a resource that we use most of the time to vertebrate, to articulate our experiences. So the next question is, okay, this is very nice. This is nice to see, but does this really work? To explain that, we always talk about this experiment that it was done by Johnson & Johnson and the Imperial College of London, in which they took 100 residents, 100 surgeons residents, or resident surgeons, and they split them in two groups. Half of them were trained with a virtual reality simulator, and half of them were trained with any other kind of resource but virtual reality. And the goal was to see if they were able, after this training, to perform a surgery with minimum guidance or supervision, okay? And the result was this one. The group trained with virtual reality, 83% of them were able to perform this surgery with minimum guidance, okay? And the group trained with other resources, but virtual reality, none of them was able to do it. This is a pretty spectacular result, but are we going to get these results in every single situation that we can imagine for training? The answer is no. There will be some situations that will be especially good to be trained, to train people in these situations with this methodology, with these resources, and there will be others that not. So the key is to select this resource whenever we know that it's going to be effective and it's going to be a really good experience. So here we have summarized some of the use cases that we know that are highly effective, because they are we have research literature that has checked that. So for everything related to soft skills, this is an ideal technology and a scenario to train people in, because people is immersed in a very realistic scenario. They are the steering role in these experiences. They need to make decisions, and their decisions are the ones that determine which way to go. So you get exposed to different situations that will very likely happen to you in your professional development, in your professional life, and then you get to see which can be the consequences of these decisions. And whenever you go to real life, you make these decisions in real life with more confidence. You have already been there. So communication, empathy, conflict resolution, decision-making, negotiations, for example. We are right now doing a negotiations experience for Doctors Without Borders, for their employees that have to negotiate conditions to access to territory in conflict zones, for example. So it's very useful for them to have a realistic training scenario in which they can train these kind of situations. They can make different sets of decisions, and they can learn from that. So whenever they go to real life, they face them with more confidence. Which is the time? 20. Okay, so this is a bunch of highly effective use cases that we have. Which are the benefits of that? We can, if you choose well the domain in which you are going to develop this training experience, if you develop it well from the design and from the technical point of view, you can multiply up per 4 times the knowledge retention in the mind of the user. This also have been proved with research studies, but it always depends on which is the subject that you are training people with, and also if it's well executed technically. Why does this happen? This happens because you are really immersed in this scenario, in a highly realistic scenario. It's not the same to be immersed in a CGI environment, in a computer-generated environment with avatars and so much that you know that this is kind of a game, than being inside here. A lot of people loses the perception that you are in a game. So they do things like waving or something like that, or things like that, because they really lose the sense that they are in a game, and so the immersion is really, really good. We can increase also empathy up to per 2 times because you are inside the situation. For example, with Doctors Without Borders, we are talking with them to produce experiences that explain which are the areas in conflict in which they are working, so they can get funding for that. So if you give a virtual reality headset to someone with 360 video, and they have the opportunity to be in a refugee camp, for example, next to refugees that are explaining their story, their situation, etc., you are much more likely to empathize with them than with other resources, because you have really the feeling of being there. Okay? If everything of this is in line, you can reduce training time up to 50%. So people learn in some situations, in some domains, 2 times faster than with traditional methods. And then you have also 100% training homogeneity. You are sure that all your employees go through the same training process, go to the same training situations. And then you have full control of which are the decisions that they made. So every single decision the user makes inside the training experience gets recorded, and you can associate a score to these decisions. So you have full monitoring of what the user is doing inside these experiences. We do that with a co-creation method. So we sit down to the same table with the experts, with the domain experts. We are experts in technology and in learning, but we don't know about a negotiation process, for example, that has to go through with Doctors Without Borders or whatever. But we sit down with the domain experts, and then we design together all the experiences. And now I want to take the last minutes of the presentation to show you some examples of what we have done. This is a project we did for the European Society of Intensive Care Medicine, in which they wanted this one. This was done in the middle of the pandemic. As you know, there was a huge lack of professionals to work inside ICUs. So they designed a learning program, a traditional learning program that they wanted to complement with a vivencial, with an experiential experience. So we designed a virtual reality, an interactive virtual reality training resource that lasted more than 2 hours, in which you play the role of an ICU doctor and nurse. There were 2 separate tracks, and you need to integrate into a team of professionals that was providing healthcare services to 2 different patients. And then you need to make decisions. For example, there was an alarm in a respirator. What are you going to do? You make a decision, we provide you with feedback, we give you the context of the situation, and you go advancing. And as I said before, this gives you more confidence to develop your work whenever you find yourself in the real situation. And with this experience, we were able to train more than 20,000 professionals. Is it running in the other window? Without sound, it blurs a little bit, but here you can see all these images are from inside the experience. Okay, so we went to Humanitas Hospital in Milan to record in the middle of the pandemics. It was a hospital that was to be brand new open, so we managed to have the opportunity to use it as a shooting scenario. And then we developed the experience through cardboard devices. Cardboard devices are virtual reality headsets that work with the mobile phone, as you probably may know. And that was a very convenient way to provide training, because doctors and nurses could take the glasses to their homes, use their smartphones, and whenever they had 5-10 minutes, they use the experience. It gets recorded the point in which you left the experience, and then you go back whenever you have time. And this was this project was it got the prize of the best virtual reality experience in health in the OE Awards, which are the best prizes from the virtual reality industry. Oops, it has come to the beginning. Let me show you also some of the cases that may interest you. This one, for example, is from leadership and negotiation. We define a situation in which you have to take a role, the role of a person that has to negotiate a situation with different people inside a company. And then again, you need to make decisions about it. You see the consequences, you get feedback about what you have just done, and you go acquiring knowledge and getting more confidence in this domain. This one is one of the first that we did. It's called Family Approach. It's about difficult conversations. This is an experience in order to improve breaking bad news to families and requesting for the donation permission. So here you play the role again of a doctor that has to break bad news to the family. Then you face different types of families: the family that gets aggressive, the family that says nothing, the family that has some medical knowledge and makes many questions to the doctor. And then you have to deal or cope with these different types of family. You get exposed to these different kind of situations, and you see which kind of things or which kind of decisions are better in order to achieve the final result, which is communicate the bad news in a good way, in a way that the family doesn't get angry and that they understand what is the situation. They fully understand what is the situation. So here, for example, one of the things that the users value most is that whenever you face the aggressive family, for example, they tell us that they really feel fear when the aggressive family stands up and they want to hit the user. So that's very important because we are able to evoke or provoke feelings in users. And in these kinds of situations, being able to manage your feelings is very useful because you really need to be calm down. You really need to measure your decisions a lot. And if you have a system in which you can practice how to control your own emotions and you are able to feel these emotions arouse whenever you are training, that's very useful for the real life. And more or less, this is what I wanted to tell you about. Let me just comment on this experience to finish. This experience we did to prepare or to train health and social work students in how to detect and manage gender violence. So we designed different situations in which there may be a situation of gender violence behind that, and then you again the same context. You need to make decisions about the situation you are being exposed to, and then you see the consequences. You get feedback. And we designed that with experts in gender violence, and this is part of the National Pact Against Gender Violence. We designed 4 resources, so there are 4 different cases in which you need to develop and make decisions, and these are freely available on the website for any person to train with that. They are on YouTube, so in YouTube they are in the format of 360 videos, so you can watch them with your mobile phone and use a cardboard device, and then you can get inside the resources. And that has been also very well received by the community. And more or less, this is what I wanted to tell you. There are some other use cases that we have, but this is what I wanted to tell you about. So if you have any questions, I would be glad to try to answer them. Thank you.
Thank you very much for this presentation. Thank you. We have time for some questions.
Hello, thanks for your nice talk. I wanted to ask because what you have explained mainly is for medical purposes and stuff, but do you have another field that you would like to dive into that you have not yet?
Yes, most of the projects that we have developed are in the health sector. That's true, but are all of them related to transversal skills? So to soft skills, which are transversal also. So for all transversal skills, this way of training, it's very good, it's very efficient. And you can apply this to almost every single vertical. We started with health because it was where we had more contacts and we started to produce projects in that sector. But in other sectors, you can also deliver projects like that related to transversal skills. And you can also mix soft skills with some hard skills. For all soft skills, training in this way is very efficient. But for hard skills, you have to look which hard skills precisely you want to train, and you have to decide if this is a good methodology or not. So I would say that you can train a lot of different verticals because our expertise is in soft skills, so improving empathy, communication, teamwork, problem solving, all these kind of things. Conflict resolution. We have, for example, this summer we have won a public contest from Universitat de Barcelona, and we are going to produce experiences regarding conflict resolution, for example, for students or pedagogy and social work.
Very nice presentation. So actually a little bit of a follow-up. So because we've discussed this sometimes, but for instance, in the teaching environment that we have here, something that we always tell the students is how to react in case of a lab accident, but mostly none of them see any lab accident in the 4 years that they are here. So for a while, there was this discussion of setting up some sort of lab accident simulator or whatever, because everything that you've shown here has a relatively time space. There is like question and answer and reply, but in other types of situations in which the development of the events is much quicker, such as an accident, I mean, can this also be implemented in the same type of methodology? That's question number one. And question number two is, given that everything is recorded, do we need to actually generate a real accident with fire and everything to record it, or how do we proceed?
Yes, for the second part of the question, the more realistic the experience is, the more impact that it has in the user. So I would suggest that yes, we should simulate an accident and record it. We are going to do it once, and then users are going to use it or are going to be able to view it many times. Okay, this is an ideal situation to be trained with that. We have, for example, we are developing a proposal for police department and for the fire para los bomberos, in order to develop these kind of situations, accidents or situations in which you need to react very fast to a very complicated situation, and develop several of them so we can expose them to different situations. For example, there is one from a crash accident. You're in a crash accident, you have people inside a car, and you have to apply the protocol to open the car and extract people in a safe way. So these situations are ideal, and the more real you can shoot it, the better, because you are going to expose the people to a situation as real as possible.
Thanks, great talk. Related to that, you've mentioned now several times that it's very important to have real humans and stuff like that, but in situations where in principle you don't need human interaction, such as, for instance, a lab accident, do you think that there it might be much more useful to have computer generated graphics, because nowadays they can be so realistic that you don't really see the difference, I think?
Yes, it always depends on which are the constraints of the subject on which you want your people to train in. For interaction with people, I would go for 360 video. Whenever there is no interaction with people, you can generate something with Unreal, for example, which is very, very realistic, with a light procedure, which is very realistic, and it will work the same way that with 360 video, probably, yes.
And then you can have more interaction instead of just having 3 choices. You could actually have the user do things.
Exactly. You can grab things, you can move things around. With the 360 video, you have a sphere which you cannot touch or modify, let's say. You decide based on options. In a CGI environment, you have much more interactivity. You can move things around. For example, for safety procedures in which you have to apply several protocols, for example, to bring something to one place and then do another thing, which is a series of steps, I would go for CGI, for example. So it always depends on the kind of training you want to do. You will go for CGI or for 360 video.
More questions? I have one, probably in chemistry after your presentation. I think that one possible application is, for instance, in our case, we have many equipment for analysis, and the departments are also in chemical companies. But basically, you have to write a protocol, how to use with the description of the steps that you have to do to measure or to have any property. Maybe to change completely the protocol, instead to have writing protocol to try to have, for instance, a QR code where you can download one of video that maybe even, as you mentioned, with the mobile phones, you can, well, with this small glasses, you can mount the cell phone there and to have all the information of the protocol directly in 3D. Then my question is, in these cases, for instance, the camera that you need for this 360 degrees video is a special camera. You can do that with a mobile phone.
Yes. Yes, we record with special cameras that has 6 lenses, and they record in 360. And then each view or each video from each lens gets stitched together to form the 360 video. And then on top of the 360 video, you can add, for example, plain videos or other resources. And for the use case that you mentioned, in which you have a laboratory and you want to interact with different places and get instructions on time, I would say that I would go for augmented reality probably. If you use a headset like a Microsoft HoloLens, in which you can scan not even a QR code, but you can scan an equipment, recognize it, and get then information regarding the protocol you need to apply with this equipment without losing sight of your physical real environment. So you augment your physical real environment with augmented reality. That would be, I would say, the best case for this use case, because with virtual reality, you get abstracted from your real scenario.
But now, well, many of, for instance, the last generation of Oculus headset that we have, you can switch between augmented
Both
reality and virtual reality. Then should be an option.
Yeah.
Okay. Thank you very much.
You're welcome.
Any further question?
Yeah, thank you for the presentation. Just for curiosity, because I presume that maybe someone is thinking about that. How much would it cost our institute to train group leaders on conflict with PhD students or master students? I mean, given that you focus on the human side of the task or the problem. So I was wondering.
Yes, that depends on the extension of the experience. We have produced experience from 15,000 euros until to 250,000 euros. The one that it's on the top is the one that we produce more than 2 hours of content, of immersive content. And then in the middle, you can do whatever. The average of the experiences is around 40,000 euros, but you can start as low as 15,000, for example.
Okay, thank you very much. Any further question? If not, we can thank you for the presentation and also to answer the questions. Now we will move to the next presentation. The next presentation, the next speaker is Alba Fombona. She studied chemistry in Oviedo, in the Oviedo University, where also she did the master in chemistry. And she was involved in focusing on chemistry, on different activities, basically for learning. We also involved in the UNED University, and then she has a relatively large expertise in Spain using these virtual reality methods to apply them to chemistry and basically learning chemistry. And the title of her presentation is Enhancing Chemistry Education through Immersive Virtual Reality, a Revolution in Learning. Thank you very much, Alba, for coming here for this symposium, and the floor is yours.
Thank you so much. Can you hear me? Okay. So good morning, everyone. I'm Alba Fombona. I came from the Energy Institute in Madrid. I came here to talk a little bit about enhancing chemistry education through immersive virtual reality. This talk came from a paper that we published last year, Virtual Reality in Chemistry, a review of scientific research on advanced atomic molecular visualization, in collaboration with Javier and Esteban. I would like to highlight this because I'm not specialized in virtual reality. I've been working in collaboration with them because we want to find out how to enhance the chemistry education. So in this case, what we have been studying is how augmented reality and virtual reality can affect and can help us to enhance the chemistry lessons. So before we move to this technology, I would like to come back to a milestone in history of visual immersion. The first film projection that it was done by the Lumiere brothers. I hope you all know about it. It happened in 1895 in the Grand Café of Paris. So this was a step forward in visualization. Why? Because with a combination of a printer and a filmmaker, they were able to project these moving images. So this is the first step where we have passive viewers. So we are seeing, instead of just images, we start to see a film. And from here, we move to another important moment, that is the transition from the analog to the digital area. Important example is the film Matrix from 1999. What is the difference in this case? That we have the digital equipment employed in this type of film. So here, in comparison with the first film that I put you, we have an interactive and an immersed audience. Why is this important? Because we step forward from being just seeing what is going on to start to use digital technologies. So from here, I would like to think about how is going the student success. We have seen that the society is facing some challenges, as it is the security, the globalization, and the technology integration. For example, we have just faced the COVID situation, the COVID pandemic, but also there is an important fact that I would like to highlight, that is the percent of the student failure. We have seen from those ages between 18 and 24 is a 14%. We are the second country in Europe with the highest level. So I think this is something important that we should think about it. And it's true that we have decreased the percent. So that's important, and I'm happy to hear that, but still we are the second country with the highest failure rate. And what are the variables that are affecting to the education level? We have seen that technology adoption, teaching methodologies, family support, the role of educators, all of these facts are affecting us. So we would like to be focused on the technology environment, how we can use this technology development that we are suffering in order to enhance the student success. Well, so here we arrive to virtual reality and augmented reality. First, I would like to talk about augmented reality. Also, I'm quite happy about the discussion that we just have. So how we can use this type of technology in order to improve the education. Okay, so augmented reality, the fundamental is that they, with this technology, you superimpose a 3D digital imaging onto reality. So here we have kind of the instructions. What you have is just a picture that you use your phone, your camera, and you can superimpose a 3D real object. So here we have an example of a molecule. So what we have is the kind of the QR, and then when you use your phone, what you see is this. Why is this important? Because we move from the 2D objects to the 3D. So now we start to see the real structures. Why is this important? Because in chemistry, I hope most of you are chemists, physics, or you already know how is a chemical structure. You know that it's not something flat. It has a structure, a 3D dimension. So here we can see how important it is that you can really see how it is. And here I would like to put an example how augmented reality is already in the schools, okay? So here we have two papers, and when you use your mobile phone, you can really see how is the heartbeats, and on the other hand, you can see how is the human body, just superimposing. So continuing with this example, I would like to show you this paper called titled Mobile Augmented Reality Assisted Chemical Education, Insights from Elements 4D. So what we have are for the cubes, and when you have it just normal, they are like this. So you have a cube with the writing the element. What happens when you use your phone? What you see is this part. For example, here we have the water. And what we can see is a liquid inside. So we can see how are the properties of this molecule. Also, in this type of program, you can see the reaction. So if you have the oxygen and hydrogen, the reaction of forming water is this one. Also here we have other examples. Well, here we have the live video, but we can see here, for example, the case of gold. We can see the difference with gold and carbon. With gold, we have a solid and yellow material that is the real one. So with the augmented reality, you can just see it like that. And you can see the comparison with another real element. And from here, we move to virtual reality. What is the main difference between augmented and virtual reality? Okay, augmented reality, you superimpose an image onto something. In this case, what you have is the immersion. The user is immersed entirely into digital environments. So here we have a video where we can see what is happening. This immersive system consists of a specific software, the head-mounted display, and a stereo sound. What it helps you is to be immersed in a real environment. You can live exactly what is going on. And as we have seen in previous talk, there are high and very important contributions to chemistry education. They can be the visualization of complex molecular structures, simulating chemical reactions and dynamics, and exploring molecular interactions. So from here, I would like to show you some case studies and examples of how successful has been virtual reality implementations. So first, I would like to start with a simple example that is the molecule of the cyclohexane. And we can see how it changed from using or from seeing a molecule in 2 dimensions to a 3D world. So the traditional representation in 2 dimensions is this one, as we already know. But then when we start to use different softwares, we can see important facts, as it can be the stereoscopic and steric effect representation. Why is this important? For example, if we move or if we focus in this picture, what we can see is that the cyclohexane is not flat. It adopts different structures in order to optimize the steric effects, because as we already know, each atom is bulky. So we need to, the structure has to be moved in order to be stable, let's say. And from here we have other examples. For example, this one is already for the virtual reality software, where you can move the 2 isomers and they ask you several questions. Also here we have an example of each lesson starts in the lab. So here we can see how we can zoom down into a pencil to see the carbon atoms. Why is this important? Because here, for example, this part, why is this important? Because we can see the vibration. I don't know if you have been in the talks that we have yesterday, but David mentioned the vibrations. Why are these vibrations so important? Why we think that having virtual reality is important for the chemistry lessons? Well, let's put the example of infrared. I don't know if you know this technique, but for example, infrared is based on the vibration of the molecule, of the atoms. So it's not gonna be the same if you see just the water molecule that is HOH, but if you can see the oxygen and the hydrogen, this type of movement, this one, all this vibration, if you are able to use the virtual reality technologies to see them, you're gonna be able to understand more this type of instruments, that is Raman, infrared, that we then use in the lab. Also here we have another example of the cyclohexane, but in this case what we have is how you are seeing through the Googles the cyclohexane. But also another important fact is that if you can see, we are in another environment. This environment is a virtual reality lab. And why is this important? Because you're not just seeing a specific, for example, protein or molecule in a specific moment. No, with the virtual reality laboratory, you are able to be immersed and working in this type of lab. And this could be interesting, as we mentioned in the discussion before, to see real situations that you can have in the lab and you can experience them there. You can repeat some experiments. So I think that's interesting. And here we have another example of how you can see not just the cyclosine, but for example, the graphene sheets. From here, I have another example. This is similar to the talks that we see yesterday. In this case, it's the employment of the Nanome software. Why is this software very interesting? For example, apart from the study for proteins, that is one of the most situations that they use to study, also you can, for example, measure the angles. So if we move back to, in this video, to the first step, let's go here. Okay, so here what we can see is how a user is creating, is working, is editing a molecule, okay? So we see how it's creating one bond, here is removing another one, creating a new one. And what the software does is that when you go to optimize, you see the decrease, no, in that bond distance in order to optimize the distance. This is important because it allows you to measure the distance and how it's going to behave the molecule. It allows you to dip into the structure. And also here, we have another important fact, that is the Nanome user that is from the software that can help you and give you instructions. This is interesting for the industries, because sometimes when you don't know if you are doing correct the exercise, or if you want to study something that you don't feel so comfortable, you have an option that helps you to keep working with that and understand the processes. So from here, I would like to give you some examples that I thought that maybe they could be interesting for you, the people that are interested into computational chemistry. So here, I give you some examples of the softwares that you can employ for different processes. Let's say, for example, for the 3D visualization of molecular structures, we have Chimera X or VR molecular viewer that they have proved to help you in this type of processes. Also here, I put you the QR, so if you want to have some or more information about them, you can just scan them, okay? From these examples, I would like to highlight specifically the educational and collaborative research environments. Why? Because, for example, ChemVR Classroom, what allows you is to be in a specific place and have this type of collaborative discussions. So it's a multi-user software where you can discuss with another person that they can be in the same classroom, but they can be in another country. So you can be having this type of discussions about a reaction, a process. So it allows you to enhance your critical thinking. On the other hand, I would like also to talk about some other companies that are involved, apart from the ones that we have seen during these days, and apart also from MetaQuiz, that it can be one of the most famous. We also have seen that IBAM is working. They are technologies, they are industries, and companies that they have a small part that is also focused in how to employ virtual reality for the educational field. And also another part that I would like to highlight for those ones that are more into the academia part, that is the example of Foldit VR. Foldit is a software employed for protein folding and docking studies. And last year, if I'm not wrong, they published a paper in Nature showing that they've been able to create, the researchers were able to create this protein folding game called Foldit, in order to have a different use. Why? Because right now the protein design in all the software, well, right now until that moment, people were used to edit that type of proteins, but they don't have the creative part. But with Foldit, they were able. Also, Foldit was quite interesting because it worked like a puzzle, no? That you were working with that and you were creating the amino acid sequence in order to create that type of protein. So between a lot of researchers from all over the world, they were able to design this type of process. So from here, I would like to highlight some of the benefits of virtual reality applied in chemistry education, as it is the enhancing of spatial understanding, the motivation, the simplify of complex problems. But specifically, I would like to highlight the remote access. We have just lived the pandemic, so we know what is being in our houses, substituting being in the lab for doing just writing reports. So now with virtual reality, we have the opportunity to have the distance education in chemistry labs. So I think this can be a very powerful tool. But as we have pros, we also have some challenges. And for me, the most important ones are specifically the technical requirements and the accessibility. Right now, we know that this type of technology is something individual. So if you want to use this type of technology in the classes, you know that you need one haptic device for each student. And right now, it's true that they are using them in universities and in college, but right now, it's not something that everyone can access to. So I think we need to work on that part. Also, it's true that some of the softwares, they cannot adapt to each level. So you can use them for example, the visualization of a reaction or for seeing a specific experiment, but you cannot substitute a full class for this type of technology. Also, we have problems like isolation or the reduce of the tactile and olfactory sensation that are important skills that we need to have in a real lab. Also, they have been reported some problems with the mental and eye fatigue. Probably this is one of the easiest parts to solve, that people are working on that. And we just see that they are programs that you can have like 2 hours of virtual reality experience. So we know that this is a easier part. So with this, what we know is that there is no full consensus on if we can substitute the real chemistry labs, the real face-to-face classes by the virtual reality. But what we know is that we can balance them and we can combine them. And we have seen that the combination of both techniques help us to enhance the student success. So now I would like to move to a particular case, that is the electrochemical desalination. Right now, as I mentioned you, I'm working as a researcher in India Energy, and we work in the environmental part. So we are focused in the desalination of water, so the sodium and chlorine capture, through the employment of electrochemical processes. So what we do is we apply current, so we polarize the electrolyte, that in our case is water with salt, and what we have is that the ions are separated, okay? So what we want to do, okay, let's go step by step. So here we have the real cell, okay? We have the cell, that is this one, that is connected to a potentiostat, that is the one, the instrument that is going to give us current, and we have a peristaltic pump. This pump is going to flow the water that we have in these 2 tanks, and it's going to recirculate the electrolyte through the cell. And also we have two sensors, ionic conductivity sensors, that are going to give us the concentration that we have. With more concentration, more conductivity. Okay. So this is the process, okay? This is the scheme. what we have is an active material that in our case is a polymer that is going to be reduced and oxidized depends on the current that we applied. So here we have the ions in purple and in green, and we are going to recirculate the water with these ions here. Also in yellow, we have an anion exchange membrane that is a very important part of the system. It's very expensive also, and it's the one that is going to allow the chloride ions to move from one side to the other one. So what we want to do is that with virtual reality, we want to walk into the cell. We want the immersive visualization of the electrochemical cell in order to teach the students how this process works. And we want to do is we walk into the cell and we can see how is the polymer, how it behaves, how is the electrolyte, how is the membrane, in order to understand how it works, how is the porosity. Also, we want to know about the electrode visualization and the electrolyte interaction. For example, here we have the main reaction. This is the polymer that we have there. This is the same one. And what happens when we are recirculating the solution that contains sodium ions and we apply current, what we have is a charge and discharge process. So in this case, it's a 2-electron process where the sodium ions will be coordinated into the polymer. With this coordination, what we have is the capturing of sodium. Thus, what we can see is in the real-time data visualization that we will have with this tool, what we are going to have is one tank more concentrated, that is going to be this one, and the other one more diluted. This is in one of the steps. In the discharge step, we'll obtain the opposite trend. And this can be, and this can be also seen with the potentiostat. So what we want to do is use the virtual reality technology to teach all these steps, to understand the engineering part, that is the design of this type of cell, then to understand the chemical reactions that are going on here, and finally, to translate the data that we are getting through the potentiostat. So what we have is when we are charging, we are having a process, so we are going to higher voltage. When we discharge, we have the opposite trend. All these things are also translated to the conductivity that we have in the tanks. So with virtual reality, we can optimize these steps to understand, for example, how has to be the flow rate that we implied, how can be the concentration, what is the voltage that we have to apply. So this is one of the steps that we would like to address the problems. So with all of this, I will just give some take-home messages. Let's say, as is like virtual reality enhance the understanding, is a platform to experiment, learn, and collaborate through an immersive, engaging, and inclusive environment. However, still we need to work in the accessibility of this technology, and we are all happy to have all the exploration with the researchers that we have here. And that's all. Thank you so much. And if you have any question, feel free just to ask. And
thank you very much, Alba, for this overview to the field. Time question. We have time for questions, of course. Questions?
Very nice presentation. So actually, do you, from the software that you've shown that has been used for learning applications, did any of those software has been statistically analyzed in terms of student performance before and after? You know, if there is like data on how the actual applications have impact the learning process?
Yeah, there are some. I mean, here is the part that I'm talking about, that there is no consensus, because in the, well, I can give you the reference with via email, because some of the papers says that they see this enhancement in numerical numbers, let's say, but it's true that a lot of them says that the comparisons of on the percentage that they are giving, they are not realistic, because they give you a value that, yes, with virtual reality, this part is enhanced in a 40%, for example, but if you compare the real conditions, you see that the case is very specific. and it's not a real case that you will face in a lab. So that's the only part. So right now, the comparison that we have, they are not realistic. We know that we can combine both, but we cannot substitute one for the other one.
More questions? I have one question is, basically, if we analyze the software that you have shown in one of these slides, showing more or less all the programs that we can employ in chemistry using virtual reality, I think most of them are made by small groups of university. There are few big projects. Probably Nanome is the exception, no? In the field, basically, the other programs are just a small group that created an application basically for the thing that they are interested. Do you think that now the situation will change? Because if not really, these programs are not, they don't have a lot of support. Basically, people are doing a project to have a program, maybe with some additional funding, but after this project, this relatively short project, they stop, and there is a program that remains and with few people using it, or maybe only in the case of Nanome is the exception. All these.
Yeah, I was trying to put these ones just because they are open access. So I thought that they could be helpful for people here, because it's true that there are other softwares that are quite more advanced, but the price, it's also disadvantaged, let's say. So that's the only, like, the main reason that I was trying to put that type of softwares, because of the accessibility that we have to them. But yeah, of course, I'm 100% sure that virtual reality is something, all the softwares that are going to start to be more and more developed. And well, right now there are foundings in Europe for helping, for example, in schools, and they provide all the technologies. And right now they have classes where they work, for example, in other areas, and to understand how was the behavior, the history 1,000 years ago. So right now it's true that we are getting more and more funded for this implementation, but still there is a long process to achieve that part. So.
Okay, thank you. Any other question? If not, we can thank Alba again. And we can move to the next presentation. Next presentation is by a member of our institute, Salomé Llabrés. Let me check the title.
It's really long.
Okay, her presentation, well, Salomé, of all of you know her. She is in the Department of Pharmacy here in Diagonal, in the campus of Diagonal, and she was working, I think, with one of the speakers of yesterday. I think you had a collaboration with David Glowacki, and you published something with him.
Yeah, that's what I'm talking about today.
And then she will present today. The title of her presentation is Development of Virtual Reality Interface for Molecular Simulation Driving Interactive Ensemble-Based Drug Design. Please, Salomé.
Thank you for the opportunity of talking about this project. I did in my postdoc. And the same thing, it was discussed yesterday. We know proteins are dynamic entities. So, however, so they sample a lot of conformations usually, but we can only see some of them with the structural biology methods, because we can only detect those conformations that are most populated due to the detection limit of the techniques. However, it would be nice to know the full free energy surface of the protein, so we could actually see invisible states that, for instance, could be interested to talk for in a computational drug design approach, because it maybe you have a cryptic pocket open, maybe you have maybe just the binding site is just not trackable. and we could design ligands that are specific for this conformation. And then you sometimes see this, like you have an allosteric effect, you have a cryptic pocket, but you almost find it by chance. So it would be nice if we could do this like in a very systematic way. However, proteins motions happen in the microsecond to millisecond timescales, which is actually beyond the reach of molecular dynamics simulations. We actually use enhanced sampling techniques to model these kind of things. However, enhanced sampling techniques are tricky techniques because you really need to know a lot about your system. You really need to know about the technique you're using, and sometimes they are tricky to set up. So after seeing one of the demonstrations of David, we had an idea. Can we use interactive molecular dynamics to use to sample these conformational motions? In fact, this is an old video from the same paper David showed yesterday, where you have to tie the knots. This I actually played with this, and it's really nice. You get a really feeling of how the protein moves. So we thought that this was a really nice way of trying to move loops and move proteins. But however, it's a matter of time scales. To the day we were started with this project, we cannot run a simulation fast enough to visualize it at the same time and interact with it at the same time. Just that the software is not fast enough. So we were wondering, can we use interactive manipulation of biomolecules to obtain a realistic description of the protein motion? So first of all, we thought, okay, just for enhanced sampling simulations, you need a huge amount of simulations. How are you going to handle that? And the most important thing was, how are we going to bias the system in a realistic way? So if you look at stereomolecular dynamics, you can see that if you pull at low velocity using low rate, you get a work that is close to the ground truth or the actual exact value of the free energy. So at the end of the day, what we have to do is do these interactive motions really, really slow. So then say, okay, we have a strategy, let's move on to this challenge. But the first thing was like, okay, I have all this way of working in the lab that I have to translate into a virtual reality prototype. So this is what my colleague screenshot looks like. And what he actually has is here, he has a lot of consoles with a Python script, with checking the NHPC cluster, and several other things. And on the other side, he has some visualization tools, because you need both. From one of them, you can get, you can analyze 1,000 of trajectories, you can submit more simulations, you can do many, many stuff. And from the other side, you actually can see one trajectory at a time and extract from visual inspection, extract some data you want to analyze. So you get some structural insights. So we thought that we could do something like this. Like this would be an analogy. We could do the same thing with VR. We could have some mission control, something that you control the analysis, you control the submission of simulations, and you control everything. And on the other side, like a launching pad, a virtual reality interface, that where you actually, things happen, the protein moves there. So that's what we did. We developed a trajectory manager and a virtual reality user interface. So I'm going to show you a video of how this looks like and how it actually works to do what we. So here you have the dual interface. And the first thing you would do is work with the trajectory manager. Here, you will see that it has a tree-like structure where you can see all of your simulations. You can keep track of all the simulations, and you can know in a hierarchical way where these confirmations come from. You can see the status, and when you want to visualize something, you just point one to a node and click here, and you enter the virtual realities. You have two controllers, one that it acts as a pointer and one that has the menu. And here you can change the representation of your protein. You can do many stuff. You can scroll through the trajectory. You can flag frames that you find interesting for whatever reason you deem relevant. And you can submit simulations from here, like, I like this frame. I want to continue a molecular dynamics simulation from this one. Also, here, when it says node fork is submitted. Now, you can bias the simulation from here. So when you enter the biasing setting, you can select some residues, and then you select a vector on which you are going to pull. Then you can select the force constant. You are going to apply the molecular dynamics simulations and the length of the simulation. And then send biasing. Once you've done this, you log out of the virtual reality interface, and you will see that here it appears two new simulations appear. One that is normal one, conventional molecular dynamics, another one that it's running, which is the biasing one. You will see that now has changed the color because it has changed the status. It informs us that now the simulation is ready to be visualized. So you can open it again, and you will see how the trajectory opens. You will see here that this loop actually starts to open slowly. This simulation is, the biasing was interactive, but the simulation is not running real time. So that's the prototype we did. And what's under the hood of this? Both the web browser, the trajectory manager, which is within a web browser, and the virtual reality user interface are developed in Unity. And the Python backend is packed in a Docker containers for portability. And you have a REST API that connects with a Python backend that is actually this Python backend that generates all the GROMACS and Plume input files necessary to run these unbiased simulations. And it submits them to the computational resources of your choosing. We actually tried two things. We tried for a local cluster at Alba and in an HPC environment at the UK. And we did all this for this particular headset, the HTC Vive headset. Okay, I found that it's really cool. You have a prototype, you see how protein moves, but is it actually useful for a scientific point of view? So we tried two things. We tried to explore folding pathways, and we tried to explore protein loop motions. For the protein folding pathways, we use GDT, which is an engineered peptide that is mostly very used in the folding studies. We know that this peptide folds at a rate of 4 microseconds at high temperature, but we can only guess that at room temperature, it's going to fold on around the millisecond time scale. One thing interesting of this peptide is that these two beta sheets, this hairpin, that is the part that nucleates the folding. Once this is formed, all the rest of the protein follows suit and folds really, really fast. There are 7 hydrogen bonds that stabilize this hairpin. And this has been attempted previously for other computational groups. David Shaw's group ran 600 microseconds of simulation at high temperature, and they were able to observe folding and refolding starting from the X-ray structure. And the group of Carlos Zimmerlin, what they did is they managed to fold the GTT from an extended structure used at high temperature and using implicit solvent, because otherwise they had too much steric lashes. So we were thinking, can we use our prototype to fold the GTT from its extended structure using explicit solvent? The thing, this is what we did at the end, and we actually made it work. You will see here that this tree-like structure here shows you the, how many nodes, how many simulations we had to submit, and which kind of simulations they were, if they are biased or unbiased. And you will see that the first one were unbiased, and it was a problem, because if you have an extended peptide and you put it in water and you send it to simulate, it would collapse. But it didn't fold in a meaning way. So we had to bias to the open conformation again, and then bias it step by step to taking both ends of this hairpin and bringing them together. Doing this, we end up with an intermediate 2, which you can see that it's not closer to the 3-dimensional structure of GTT. So then what we did is try to force the formation of different hydrogen bonds of this hairpin. We realized that with the pair 13 to 17, this was not working, and neither was the pair 12 to 18. But the hydrogen bond from the lysine 10 to the tyrosine 20, once you form it, everything starts to fall together. In fact, the last node we submitted on these simulations, it was just unbiased. We took a structure that was close to the crystallographic structure, and it just folded. And it went, we obtained a structure that was had an RMSD of 2 angstroms away from the crystal structure. And if you look at just the C alphas, it was 0.7 angstroms away, with an aggregated simulation time of not even 65 nanoseconds. Well, just to check, we did a control simulation. We just took the extended structure and let it simulate, let it run for 1.5 microseconds, and it was not any closer to folding. So we were really happy with this test. So we said, let's gonna try something a bit trickier. Then we try to sample loop motion. This is cyclophilin A, and this is a protein that was an ongoing project in Julien Michel's group, and it has is the target of cyclosporine, and it has 2 loops that shape the binding site: the 70s loop and the 100s loop. And by NMR, we know that these loops are highly dynamic. In particular, the 70s loop is especially critical for the dynamics of the protein. And you will see that here, in the middle of the 70s loop, you have an aspartate that forms 6 hydrogen bonds with all the residues in the loop. So the 70s loop is quite tight. And at the same time, we developed this prototype, but there was a work ongoing in the group where they actually did accelerated MD of the opening of the 70s loop, opening of the 100s loop, to obtain a set of started structures that were used to run conventional molecular dynamic simulations and to generate a Markov state model. We ran this cycle here until the Markov state model was converged. And that gave us a conformational ensemble with the kinetic rates that were related to the movement of these loops. Then we said, okay, if you ever use accelerated MD, it's a bit, you have to set a couple of parameters, which is not, it's not really difficult to set up, but you have to tune a couple of parameters and you have to restrain the rest of the protein from unfolding. So we said, can we change the accelerated MD for the VR prototype? And that's what we tried. And we used the VR to get the loop open and the loop closed. So these are the metastable states visited while we are using the accelerated molecular dynamics, and the metastate visit during the virtual reality prototype. They were really similar. Maybe it's true that with the virtual reality, the changes were a bit abrupt, but the conformations we got, it was not significantly different. So we took these conformations and we did the same. We get the starting structures, we run a lot of molecular dynamic simulations, and we generate a Markov state model again. And if we compare the two Markov state models, we get some hints of how virtual reality works for this as an enhanced sampling technique. I'm going to explain here. This is the part where the 70s loop is closed, and here's the part where the 70s loop is open. And this transition goes through an intermediate state. Here you have the 100s loop closed, and here you have the 100 loops closed. When we compare both models, what we see is that the relative population of the open and closed state of the 70s loop is quite similar, although virtual reality slightly overestimates the open state. But it's all within error bars, because you will see they're quite high. And when we look at the transitions and the mean first passage times, you can see that we observe faster kinetic rates between states, about 3 times faster for the virtual reality ensemble. But again, they are within error bars. Here you have 30 microseconds for this step, and here you have 10. You will see that more or less it's something like that. It's true that we run a few less microseconds of conventional molecular dynamics, but the results were quite consistent, and the Markov state model was converged. So going back to the things we wanted to know, does the conformations we sample using this protocol with the VR compare with the conformation sample with the accelerated molecular dynamics? They actually do. These are the RMSD loops, the RMSD of the loops, comparing the structures that came from the VR and from the accelerated MD. And you will see that all of them are within error bars, one of each other. So we were really happy with these results. And just to conclude, I'm going to say that we developed a virtual reality method that could be used as an enhanced sampling technique, that we were able to incorporate interactive biases and still retain a realistic description of the conformational motions of the protein. Our prototype has a dual interface that has different capabilities for the trajectory manager of the user interface, but altogether work in a way that you can submit simulations in an easy way, and you can keep track of all your simulations easily. We did some validation tests, and we are actually quite happy. I'm very proud of the work we did with cyclophenol A, because our results actually compare to accelerated MD, which is a broadly used technique in the computational science. However, there's a limitation on this. I mean, all the things you do are based on visual analysis. And visual analysis is a thing, it's actually subjective. So 2 people using the same prototype with the same protein will get slightly different results, because it depends on what you know of the protein and how you might work it with the VR. Therefore, we suggest that in the same way we did with the Markov state model, you use another technique to validate your hypothesis. And last, this prototype was an a huge success as an outreach tool. We showcased it in the Edinburgh Science Festival, and it was an amazing success. And we had some high school students were coming to the lab, and they were testing. And I mean, they're high school students. They didn't know which are the amino acids of a protein, but they end up getting the feeling of how a protein moves and which are the residues, what interacts with what. And we were quite happy with the results. And last but not least, I want to acknowledge all the people involved in this project, the group of Julian Michel, which was my postdoc supervisor, Dr. Jote Juarez Jimenez, who is now also at the Institute, and the group, David and his team, that time they were at the University of Bristol, now at CITUS, and Interactive Scientific, which was our industrial partner in the ERC Research Council proof of concept grant. The computational resources, and all of you for your attention.
Thank you very much, Salomé, for this nice presentation and how we can apply virtual reality for research in chemistry. We will have time for questions.
Very nice presentation. So I actually have one question related with the last part of your presentation, in which you shown that different users arrive to different. So do you observe any sort of convergence to a most common output, or there is like a complete dispersion of results as a result of users? And if that is the case, do you think that is it possible to somehow average the different results in order to get like a more broad overview of the potential energy landscape, or if you can extract any information of these different outputs?
I think it's a very interesting question, because it was 4 people in the lab that we tried this prototype, and we saw that we actually move different things. We have a different feeling of things, but I think that it was just us. So I think for people, it's not enough to get any statistical analysis of this. But I think that it would be nice, the same way David showed yesterday, that with the reactions, if you get a lot of people to try, you will get a lot of different views of the thing, and probably it will help to sample the free energy surface of the protein, for sure. The thing is, there has not been a lot of people trying this.
Any other question? Well, if not, sorry.
Thanks for the presentation. I'm curious, are you using this methodology now for running your molecular simulations, dynamic simulations, and all that?
No, I'm not using it now. I mean, it's available. It's in a Bitbucket, so you can use it. But yeah, the VR set stays in Edinburgh, so we don't have it. But we could try here. I don't know, maybe.
Okay.
Thank you.
More questions? If not, we can thank Salomé and all the speakers of this morning session. In principle, I think it's not raining. Then I think we have the tables for the coffee break just over there. Thank you very much. We will come back at 12, okay?
Okay, so we will start with the second half of today's session on the new trends on virtual reality. So our first speaker is José Antonio Muñiz, who's the founder and CEO of the Digivision. That's a company that he founded when he was 18 years old. That was some years ago. The company has evolved through different aspects of entertainment, audiovisual, media production, and so on. And more recently, his company and the work that they've been doing is trying to establish synergies between things in which virtual reality or augmented reality tools can be relevant for research. For instance, he has a project with the geology faculty to develop a sort of a time machine in which you can accelerate geological processes and use the same technologies that you are developing for research in order to bring them to the general public. So apply these tools for entertainment, which in turn can provide with feedback that can be reused for research proposals. Okay, so José Antonio, cuando quieras.
Gracias. No sé si se me oye bien. Bueno, muchas gracias por invitarme. La verdad es que yo siempre me encuentro un poco intruso en estas cosas, que ya me ocurre a menudo. Pero bueno, en realidad yo cuando era joven iba para físico, me gustaba mucho la física, me gustaba mucho la astronomía, pero a los 14 años, bueno, me gustaba mucho la astronomía, me gustaba mucho la física, pero también me gustaba mucho la ingeniería. Así que tenía un poco el problema de que cuando llegara a estudiar mi carrera no sabía muy bien qué iba a hacer. Al final me pasaron dos cosas. Primero que me encontré con la serie documental de Cosmos, de Carl Sagan. Muchos igual sois muy jóvenes para conocerla, pero seguro que hay gente más mayor que conoce esta producción. Y lo segundo es que mientras estaba haciendo el bachillerato hice una ingeniería en electrónica digital, tuve la ocasión, y de ahí salté a los ordenadores, microprocesadores, y a los 18 años pues casi no había nadie a mi alrededor que supiera montar redes, ni hacer imagen por ordenador, ni imagen digital, y fundé una empresa que se llamaba Digivision, que ahora parece un nombre como un poco tonto, un poco imaginativo, Digivision, pero os garantizo que cuando yo tenía 18 años, tengo ahora 54, pues no era muy habitual. La gente decía, ¿Digi qué? ¿Cómo? No entendía muy bien eso de Digi, de qué venía, porque digital no había absolutamente nada, ¿vale? No teníamos internet, no había prácticamente nada. Cuando yo monté mi empresa, la idea era hacer documentales de televisión que tuvieran gran impacto, como pasaba con Cosmos, vinculados mucho a lo que es la ciencia y tecnología para mejorar el mundo, ¿vale? Y me encontré con la dificultad de que la televisión normalmente, la televisión tiene, digamos, unas prioridades de hacer lo que se llama, o lo que son programas sensacionalistas, ¿no? Por no ir un poco ya a hablar de telebasura. Como podéis ver, tenemos unas inversiones absolutamente brutales en series de Netflix, películas de zombies, superhéroes y bueno, todas estas cosas que están muy bien para el entretenimiento, pero creo que nos estamos, y creo que estaréis muchos de acuerdo conmigo, en que creo que nos estamos pasando un poco con las cifras que estamos destinando a este tipo de cuestiones. Bueno, yo la verdad es que he intentado llevar a Digivision en un camino para disfrutar mucho de la ciencia, de la tecnología, por un lado, para investigar y estar ahí, estar ansioso para las cosas que llegan. Nosotros no somos una empresa que nos inquieta lo que viene y nos agobia adaptarnos o tenemos que hacer esfuerzos para adaptarnos, sino que estamos nerviosos por esperar que lleguen las cosas. Ya sabemos lo que va a llegar, ¿no? A nivel de realidad virtual, a nivel de comunicaciones, alta velocidad, tecnología audiovisual, etc. Entonces, Digivision ha tenido varias líneas. Primero hemos trabajado mucho para el sector de la industria, hemos trabajado haciendo simulación, mientras todo el mundo hacía dibujos animados y hacía efectos especiales para Hollywood, nosotros animábamos los motores de Rolls-Royce para explicar cómo funcionaba un turborreactor. O animábamos para Pierre Fabre cómo funcionaba un medicamento para aumentar cualquier propiedad, ¿no? Y también en paralelo empezamos a trabajar con estas animaciones para los institutos de investigación. Hablamos de CSIC, hablamos de institutos, por ejemplo, como ICFO, que imagino que muchos de vosotros conoceréis. Y claro, te encuentras un poco que los institutos de investigación, como bien sabéis, en investigación, como hay tantísimos recursos, pues claro, ¿qué pasa? Los pocos recursos que te caen, automáticamente la tendencia normal y lógica es dirigirlos inmediatamente hacia investigación, como es normal, ¿no? Y entonces nos olvidamos de hacer difusión. O si hacemos difusión, lo hacemos de una manera en que no llega y no tiene impacto. Entonces, bueno, una de las cosas que yo hice con esta historia, como era un empresario que quería cambiar el mundo y tengo mi alma filantrópica, dentro de mis posibilidades, a los institutos de investigación, intentaba producir lo mejor posible con los recursos que ellos tenían. De esta manera, hacíamos simulaciones por ordenador para explicar líneas de investigación que ayudaban además a encontrar mecenazgos, etcétera, ¿no? Y además era un ambiente muy bonito porque ayudábamos muchas veces a conectar empresas que sabíamos que lo que estaban haciendo con líneas de investigación que sabíamos que podían ser muy interesantes para estas empresas. Ahora un instituto como ICFO es tremendamente agresivo y potente y ambicioso en hacer esta conexión empresa de todo lo que es transferencia de conocimiento, pero yo os garantizo que hace 30 años esto no pasaba. Era muchísimo más difícil. Bueno, entonces, fijaros, nos encontramos haciendo simulación por ordenador de procesos industriales, nos encontramos haciendo simulación por ordenador de líneas de investigación en institutos de investigación. Y luego, en paralelo, nosotros empezamos a hacer nuestras primeras series documentales, ¿vale? Claro, si tú vas a una televisión muy importante, o sea, para tú poder hacer una producción audiovisual, tienes que convencer a una televisión de que te ponga una cifra relevante de dinero. Si tú vas a una televisión y le dices que vas a hacer una serie documental sobre fotónica, pues lo más probable es que te digan que a lo mejor esa no es la mejor temática o que seguramente no van a tener una gran audiencia con esta temática. Así que al final te empujan a que hagas temas mucho más sensacionalistas otra vez, que puedan estar vinculados pues con cosas muchísimo más atractivas, ¿no? Pues ya sabéis un poco los documentales que hay por ahí, ¿no? Los puentes más grandes, el avión más grande, el arma más poderosa y todas estas cosas, ¿no? Claro, ¿qué pasa? Nosotros hasta que no tuvimos dimensión suficiente como empresa para empezar a financiar nuestras propias producciones, no pudimos arrancar producción potente porque no estábamos de acuerdo en lo que la televisión nos estaba pidiendo. Incluso cuando dábamos una buena idea, estas televisiones a nosotros nos decían que los guiones eran demasiado didácticos o que el nivel era demasiado alto para la audiencia y este tipo de cosas. Es decir, esta sensación un poco de tratar de idiota al espectador, que es un poco lo que suele ocurrir pues, en muchas de las producciones que ocurren. Hicimos una serie con producción propia que arrancamos nosotros solos, que no sé si algunos de vosotros habréis visto, que es Ingeniería Romana. Los ingenieros romanos conocían perfectamente. Aprovechamos a hacer esta serie porque teníamos muchísimos modelos virtuales de proyectos que habíamos hecho de yacimientos arqueológicos, ¿vale? Es una serie en la que integramos, esta serie ya arrancó el primer episodio en 2015 y es una serie en la que utilizamos ya el concepto de los escenarios virtuales, donde ponemos elementos virtuales que el presentador interactúa con ellos y que tenemos simulación de partículas, simulación de fuerzas y este tipo de cosas que son esfuerzos que normalmente en documental hace años no se hacían. Ahora cada vez son más económicos y son más factibles de hacer. Fijaros que os digo que pudimos hacer esta serie nosotros solos o arrancarla nosotros solos porque, voy a enseñar a ver si consigo por aquí algún, por ejemplo, mira, este es un buen ejemplo. Si os fijáis, por ejemplo, estas termas de aquí, que son las termas de los Bañales, Zaragoza. Nosotros ya teníamos este modelo virtual hecho por un encargo del Gobierno de Aragón y una de las cosas que hicimos fue levantar los modelos virtuales cuidando al máximo la planimetría de los arqueólogos y los investigadores, integrando las nubes de puntos y toda la información planimétrica que tenía. ¿Qué es lo que eso nos ha permitido hacer? Superponer los modelos virtuales perfectamente a los yacimientos. Es decir, si nosotros, en el momento que se nos encarga el trabajo de este yacimiento, hacemos los modelos virtuales como todas las productoras hacen, deprisa y corriendo, para lograr las animaciones lo antes posible de lo que se nos está pidiendo el Gobierno de Aragón, nosotros no hubiéramos tenido unos modelos virtuales preparados para ser integrados ahora sobre imagen real. ¿Vale? Un ejemplo un poquito más flagrante. Esto es Ampurias, por si lo conocéis. Entonces, todo este contexto que, bueno, antes de que pase un poco al tema del aprovechamiento de los modelos virtuales, deciros de que Ingeniería Romana es el documental más visto de la historia de televisión española. Tiene 100 millones de visualizaciones al año por episodio en YouTube, porque nos negamos como productora a cerrar los derechos. Llevan más de 100 festivales ganados y ahora todo el mundo quiere producir con nosotros. ¿Vale? O sea, todas las críticas que teníamos de que la serie es demasiado técnica, que se explicaban conceptos de ingeniería demasiado altos, ha representado una audiencia enorme, que van desde niños de 8 años que ha salido en el país, niños con problemas de déficit de atención, que los padres se ponen a llorar porque se quedan atrapados 2 horas delante del televisor, hasta gente muy mayor que desde luego no tienen formación por su edad y por las circunstancias que ha vivido de una ingeniería, no entienden cuando hablamos de cotas y de niveles y de este tipo de cosas, pero entienden perfectamente el volumen de trabajo que los ingenieros romanos abordaron en ese momento. Entonces, nosotros estamos concentrados en, bueno, dejar esto de fondo, estamos concentrados en hacer grandes producciones de temáticas en ciencia, tecnología e historia, ¿vale? Hemos tardado una década en tener la credibilidad de que producir de esta manera es rentable y además logramos grandes audiencias. ¿Vale? Entonces, tenemos una serie de fotónica en proyecto con ICFO, donde vamos a hablar de cosas apasionantes, entre ellas el tema de química. Y os enseñaré, por ejemplo, que igual que nosotros cuando hicimos los modelos virtuales que nos encargó el gobierno de Aragón que hiciéramos un yacimiento para enseñar cómo era, nosotros para ICFO hacemos multitud de animaciones, multitud de trabajos de simulación y de vídeo. Y os puedo enseñar, por ejemplo, cosas tan potentes como esta, ¿vale? Ahora voy a ser comercial de ICFO. Están desarrollando un chip muy pequeñito, creo que son 2 milímetros cuadrados, que lo que te permite es que pones una gota de sangre y te hace un hemograma inmediatamente que te manda los datos al teléfono. Analítica inmediata, marcadores tumorales, infecciones bacterianas. ¿Qué pasa? Cuando nosotros trabajamos esto para ICFO, hemos hecho esfuerzos especiales como empresa para que los modelos virtuales estén preparados y sirvan para hacer todo tipo de proyectos posteriores. Llámese el portal del metaverso del Instituto de Investigación para que la gente pueda visitar las líneas de investigación, ¿vale? O llámese, por ejemplo, el tener ya unos modelos virtuales que te permitan hacer simulación. Antes he visto la ponencia anterior, todo el tema de proteínas y tal. Claro, esto es absolutamente brutal. Otra cosa, además, para que veáis un poquito también la dimensión de los temas que estamos hablando. Por ejemplo, ICFO nos habla de nanopinzas. Nos habla de nanopinzas, por ejemplo, que es una manera de sujetar partículas con luz y con esta tecnología pues podemos hacer ahora nosotros producimos cosas como esta, en la que explicamos en documentales muy amenos de que somos una gran civilización porque podemos coger cosas. Imaginaros un delfín cómo podría progresar, por muy inteligente que sea, si no puede coger cosas. ¿Vale? Y aquí ponemos toda una escena para explicar de que cogemos cosas muy grandes, cogemos cosas muy pequeñas con muchas más dificultades, pero que la luz nos da una... Bueno, imaginaros aquí tenemos una simulación. Fijaros, por ejemplo, las imágenes, traveling, súper bien iluminadas, son los recursos de Hollywood puestos a que brille la investigación. ¿Vale? Lo digo porque, claro, cuando yo voy a ICFO no les puedo plantear gastar este dinero. Me dirían que estoy loco, no pueden destinar todo este dinero a Hollywood porque tienen que destinar el tema a investigación. Pero nosotros como empresa hacemos los esfuerzos. Y esto nos permite luego poner si os fijáis las imágenes, si hacéis vídeos muchas veces de investigación os daréis cuenta de que tenemos imágenes amarillas y tal, y sin embargo luego veis CSI en la tele y estos de CSI parecen mucho mejores que nuestros equipos de investigación de aquí, ¿no? Bueno, pues es un poco el tema de los recursos en imagen que podemos poner en este tipo de producciones. Y estos esfuerzos llegan a los modelos virtuales. Con los modelos virtuales que nosotros hicimos de ICFO, nosotros ahora podemos hacer producciones audiovisuales en las que enseñamos los conceptos de sujetar cosas con luz, que en este caso es una nanopartícula.
Ahora sí podemos sujetar cosas.
¿Vale? Poner la épica de Hollywood y, bueno, explicar que podemos sujetar un glóbulo blanco o podemos sujetar un glóbulo rojo. La técnica que ellos utilizan para sujetar un glóbulo rojo es poner unas proteínas especiales, estas nanoesferas, que permiten sujetar al glóbulo rojo y ahora lo sujetamos con estos haces de luz super focalizada, por ejemplo. ¿Vale? Entonces, el mensaje un poco es que, un poco otro ejemplo, bueno, voy a dejar un poco aquí las animaciones. El mensaje es que podemos utilizar financiación de series de televisión, que son de millones de euros, para financiar modelos virtuales y parte la creación de modelos virtuales, incluso líneas de investigación, que va a generar contenidos que van a alimentar estas series documentales. Y cuando hablo de series documentales, hablo del concepto transmedia. Es decir, no solo ir a televisión con series, sino hacer píldoras mucho más pequeñas que van a redes sociales y abrir ya las puertas a todo el tema del metaverso. ¿Vale? O sea, si nosotros encargamos un audiovisual, el tema de los yacimientos arqueológicos es muy evidente. Nosotros encargamos un audiovisual para explicar nuestro yacimiento arqueológico, contratamos esto a una empresa, esa empresa tiene que levantar unos modelos virtuales, nos entrega un vídeo y ya está, nos hemos olvidado. Tenemos un vídeo que a los 2 años es caduco. ¿Qué pasa con los modelos virtuales? Los hemos perdido de vista. Pues es un gran, los modelos virtuales es un gran activo, es un activo enorme. Y entonces es fundamental trabajar en una línea en que podamos unir todo esto. Os explico un proyecto muy bonito para que veáis a qué nivel de impacto tenemos, pueden llegar este tipo de cosas. A nosotros se nos llama del Geoparque de Trem y se nos pide que hagamos un proyecto maestro para poner en valor todo lo que es el tema geológico paleontológico del parque. Y desarrollamos un proyecto para convertirlo en un museo al aire libre a base de animaciones por ordenador, simulaciones, que permite animar las montañas, de forma que comprendes la formación del geoparque y la formación de los Pirineos, y al mismo tiempo los yacimientos paleontológicos para entender cómo fueron los últimos dinosaurios de Europa que estuvieron aquí. ¿Vale? Este proyecto, cuando salieron los Next Generation, alineados a la investigación, que unían investigación con impacto en territorio, con digitalización, con turismo, etc. Presentamos un Next Generation en la Universidad de Barcelona por la parte de geología, el Instituto Catalán de Paleontología, el Consorcio de Geoparque y nosotros como PYME. Y a los 3 meses lo teníamos concedido. Y de esos 860.000 euros que nos han concedido, 200.000 son para generar contenidos y hacer una experiencia piloto de ver cómo esos contenidos en el geoparque son de atractivos y funciona la idea. Pero el resto, los otros 600.000, van a investigación del ICP y del Geomodel, del Departamento de Geomodel desde aquí de la Universidad de Barcelona, para crear modelos virtuales que sirvan para que luego los artistas digitales puedan rápidamente animarlos. Y viceversa. ¿Qué pueden hacer los artistas digitales cuando animemos todo el tema geológico? ¿Cómo podemos devolver eso a los investigadores de forma que les sea lo máximo útil para sus investigaciones, para su difusión, para sus ponencias? ¿Vale? Entonces, yo un poco la reflexión que creo que tengo que haceros es que si estáis trabajando en todos estos proyectos, vigilad la cuestión transversal. Lo importante es que penséis todas las dimensiones y derivadas que todo esto tiene. Porque ya os pongo un tema más cercano a vosotros, que es este proyecto de aquí. Que es una serie documental que habla del cáncer, ¿vale? Tenemos aquí, estamos trabajando toda la parte documental con los equipos del Clinic y el proyecto base es crear unas bases de datos de proteínas, de recursos audiovisuales, de recursos virtuales en el funcionamiento celular, etcétera, etcétera, que nos permitan tener modelos virtuales y materiales de docencia, ¿vale? Vamos a ver hasta qué punto los podemos enganchar con investigación y a partir de ahí generar materiales docentes para la propia universidad, ¿vale? Y luego que esos mismos materiales sirvan para hacer las simulaciones por ordenador que nos van a permitir explicar a la sociedad qué es el cáncer, qué pasa en nuestras células y qué están haciendo nuestros equipos de investigación para resolver este problema. Y este es un poquito el concepto general que os doy. Entonces, pensad, tenemos tecnologías potentísimas que se trabajan en Hollywood para modelar y levantar modelos virtuales que los investigadores no conocen. ¿Vale? O sea, con nosotros estamos trabajando aquí con el equipo de geología, tienen sus softwares para calcular el movimiento de los movimientos geológicos, para la evolución en el tiempo, etcétera, pero están sorprendidos con las herramientas que se utilizan en Hollywood y que los artistas digitales utilizan para simular ciertas cosas. Entonces, todo esto hay un camino de fusión y de matching que es fundamental y tenemos unas líneas de investigación ahí brutales y cuanto antes hagamos este matching, pues muchísimo mejor. Porque cuando hagamos esfuerzos brutales en levantar modelos virtuales o herramientas de simulación, podemos hacer una herramienta de simulación muy potente en un tema de investigación, pero probablemente con muy poquito más podemos tener una herramienta de docencia, ¿vale? O podemos tener unos materiales brutales para poder hacer difusión. Te puedes encontrar con un software que lo estás desarrollando con 100, 150, 200.000 euros, que es el presupuesto que tienes el equipo para hacer el desarrollo del software, 300.000 euros, pero te encuentras que una serie como esta puede tener 4, 5, 6, 7, 10 millones de euros o de dólares de presupuesto. Y cuando planteamos hacer esta serie, tenemos que animar cómo funcionan las proteínas, cómo funcionan los mecanismos celulares. Podemos bajar dinero desde este proyecto a investigación. Y entonces a ver si conseguimos hacer esta rueda que siempre nos falta. Es decir, que la investigación se ve poco porque invertimos poco en difusión de lo que se hace esa investigación. Entonces, si fuéramos capaces de contar bien lo que se investiga, pues nos daremos cuenta de que es tremendamente más interesante que la serie de ficción que tenemos en la tele. Y esto, por ejemplo, te lo demuestra, por ejemplo, Chernobyl. Imagino, no sé si es una producción que habéis conocido o que conocéis, que habéis visto, que es una serie que es tremendamente rigurosa desde el punto de vista científico, ha sido un gran éxito de audiencia, y si tú ves esa serie conoces perfectamente la historia de lo que pasó con todo lujo de detalles y señales, ¿no? Pues esto es lo mismo. ¿Qué pasaría si los 330 millones de dólares que se gastaron en hacer Spider-Man 3 lo gastáramos en hacer una serie de ciencia? No lo ha hecho nadie eso. Yo creo que tendríamos más audiencia, probablemente. Bueno, no sé si alguien quiere preguntar alguna cosita en la línea de lo que he dicho, o no sé si es útil lo que os estoy contando.
Por supuesto que sí. Vamos, preguntas de la audiencia.
Muchas gracias, estoy flipando literal con todo lo que has contado. Tengo dos preguntas. Una a nivel curiosidad es si quizá tendríais una especie de tras las cámaras de cómo se anima todo lo que has mostrado. Y la otra es si crees que en vez de hacerlo tipo producción, podría ser material interactivo para la docencia y tal, así como dices que también se puede destinar a investigación.
Claro, claro. Fíjate, por ejemplo, bueno, material sobre los making of de cómo hacemos las cosas. Los que tenemos son muy visuales, de la gente en campo grabando, en el plató filmando, los equipos de postproducción quitando los fondos verdes de los cromas, ¿no? O ahora en los platós que los fondos están hechos con pantallas de LED. No sé si habéis visto que nuevas tecnologías. No aporta mucho. Lo que sí es cierto que, por ejemplo, del proyecto Geocult, que es el proyecto Next Generation que nos han dado con la UV, con el tema de geología, y el ICP con el tema de paleontología, de ahí van a salir muchos papers, van a salir muchos informes, mucho material de cómo se está trabajando y cómo se está aprovechando para que otros equipos de investigación y otros artistas digitales tengan ya un conocimiento y un proceso de trabajo por el que no tengan que pasar, porque es duro, ¿eh? El tema de los dinosaurios, puedo enseñar, mira, estos son animaciones creadas a partir de los trabajos con el ICP, ¿vale? Estos son dinosaurios de 18 metros de largo que vivían aquí en tren, ¿vale? Aunque aquí, pues, no lo sabemos. Fijaros, por ejemplo, todos estos escenarios son completamente virtuales. Esto no está rodado, está completamente virtualizado. Esto no está del todo acabado. Pero ahora, por ejemplo, toda esta piel la tenemos que acabar, hay que cambiar, porque hay un nuevo hallazgo, hay una nueva excavación donde se ha encontrado incluso fosilizada parte de la piel. Y ahora sabemos que hay unas escamas enormes. Entonces tenemos que cambiar la piel y tal. Pero estos módulos virtuales están perfectamente preparados y entregados al propio ICP. Y al ICP se les está formando para que los utilicen, ¿vale? Entonces, desde la propia UV a mí se me ha llamado de cómo poder hacer un aula de realidad virtual, qué tecnologías utilizar, qué criterios utilizar a los investigadores y a la gente que está creando contenidos para que esos contenidos sean aprovechados al máximo, ¿vale? Porque pensad que hasta ahora yo hago una simulación de un tema de proteínas o de un tema de enlace químicos o lo que sea y tengo software muy específicos para lo que estoy buscando. No son visuales. No son capaces, por ejemplo, de exportarlo luego fácilmente a aplicaciones de móviles o de llevarlo a un aula virtual que pudiera estar en la universidad, ¿vale? Porque nos estamos olvidando de que el rey en todo esto es un real, que es el software que se utiliza para los motores de los juegos para los juegos virtuales de máximo nivel que ahora estáis viendo, prácticamente el 90% están hechos con tecnologías de Unreal. Entonces, Estar atentos para que todos estos procesos de trabajo, estos modelos y tal, estén encaminados y enganchar rápidamente con esto es fundamental. Porque eso es lo que nos va a permitir luego que estas animaciones, estos modelos de qué es una falla, cómo se hace un encabalgamiento geológico y todas estas cosas, estos modelos se están preparando para que alguien en el geoparque venga con unas gafas, venga con su móvil y lo vea superpuesto y comprenda cómo esa montaña o esa falla de enfrente se ha formado, o ese valle, o esas huellas, que comprenda los animales que lo formaron. ¿Vale? Esto es lo que estamos pretendiendo. Pero es que además el Departamento de Geología de la UB se va a quedar unos modelos que van a estar, unos modelos virtuales que van a estar animados para poder interactuar con ellos en motores de realidad virtual. Y tenemos ya la base de poner proyectos docentes de realidad virtual. Porque olvidaros ya de que las clases van a ser así. Las clases no van a ser así. Esto es gente sentada alrededor con unas gafas, todo el mundo viendo lo mismo, y el guía o el teacher señalando las cosas delante de nosotros, ¿vale? Entonces, después de sentados vamos a ir a que nos vamos a poder mover. Tendremos una sala como esta, abierta, y cuando vamos a tener un dino de este tipo, pues vamos a poder estar hablando de 1000 cosas. Si os fijáis, por ejemplo, esto es súper bonito. Esto no es una animación sensacionalista de National Geographic para un documental sobre dinosaurios. No sé si os fijáis que es increíble. Os lo digo como curiosidad, porque es una cosa que, si os fijáis cómo andan estos dinos, hay un momento que tienen... Qué bien. A ver. Hay un momento que tienen las dos patas, o sea, las dos patas apoyadas de la izquierda. No sé si os fijáis. Bueno, no voy a ir allí. Pero que fijaros que, por ejemplo, no sé por qué pasa eso. Hay un momento, ¿cómo puede ser que un animal de tantas toneladas? Pues esto está súper investigado. Los paleontólogos nos dicen que está así. Y hemos utilizado softwares de fuerza para comprobar todas estas cosas, que para ellos a veces les cuesta comprobarlo. Estamos haciendo un matching de tecnologías y tal. Ellos cuando intentan animar sus dinos, no tienen tecnologías. Cuando vosotros veis los dinosaurios del Parque Jurásico, os daréis cuenta de que son muy distintos a los dinosaurios que salen en los documentales. Los de los documentales parecen animales ahí toscos, de plástico, y cuando ves Parque Jurásico, parece que ¿dónde los han grabado? Que parece que existen. Pero ¿eso por qué es? Eso es porque cuando tú haces un dinosaurio al estilo Parque Jurásico, tienes toda la musculatura construida por dentro. Tienes los modelos virtuales de los músculos. Tienes la piel que resbala en la medida que tiene que resbalar. Tienes todo el sistema de esqueleto, lo que se llama el RIG de movimientos, el diseño de movimientos de interior y las reglas que rigen el funcionamiento del movimiento del dino, lo tienes integrado dentro en fórmulas. Si yo quiero hacer un documental rápido para sorprender a la audiencia, con hacer dinos de plástico y no sé qué, no sé cuántas, no es suficiente. Pero si quiero hacer dinos rigurosos en movimiento, en no sé qué, no sé cuántas y tal, probablemente tengo que aplicar estas tecnologías que en realidad se han utilizado primeramente para conseguir dinosaurios en superproducciones de Hollywood. Entonces, este aprovechamiento es fundamental. Y entonces, bueno, pues si tú ahora quieres hacer un tema de realidad virtual en docencia, pues ahora empezamos a pensar. Pero nadie había pensado en los motores de los juegos, de los videojuegos, que son los que van por delante. Entonces, este matching es muy importante.
Gracias por la presentación. Un par de preguntas rápidas porque vamos fuera de tiempo. Bueno, aquí en el instituto habíamos tenido una persona experta en Maya y en animaciones para hacer cosas. El único problema que tenemos es la competencia con las empresas de videojuegos y los salarios. Y realmente se fue por un tema económico, pero bueno, habíamos intentado hacer, bueno, estuvo un año trabajando aquí. Respecto a esto, por ejemplo, las animaciones que habéis hecho al ICFO, ¿El objetivo final que son colocarlas en la web básicamente y para alguna presentación del instituto, no me imagino?
ICFO utiliza fundamentalmente esas animaciones y esos materiales para encontrar mecenazgos para sus líneas de investigación. Suele ser normalmente el detonante número 1. Luego, evidentemente, sirve para temas de difusión del propio instituto y transferencia de conocimiento y tal, ¿no? Pero normalmente cuando nos llaman para decir, oye, tenemos que enseñar con mucha claridad cómo funciona esto, porque tenemos que encontrar inversores, mecenazgos y tal, ¿no?
Me imagino que son animaciones de 2-3 minutos, ¿no? O también las hacéis muy largas.
Tenemos muchísimas animaciones de, bueno, hay de todo tipo, ¿eh? O sea, de ICFO he cogido un puñado, pero ICFO llevamos 10 años trabajando para ellos y tenemos muchísimas cosas. Pero, por ejemplo, mira, cuando ellos hablaron, ellos intentaron ganar, que lo ganaron, por cierto, un experimento en la Estación Internacional Espacial. Pues aquí hacía falta mecenazgo para poder financiar. Ellos siempre son ambiciosos a la hora de contar sus proyectos y encontrar apoyos económicos importantes y tal, ¿no?
No, sí, ya los conocemos.
Bueno.
Y la última cosa, así rápido. ¿Y de qué orden económicamente, de qué orden de precio, por ejemplo, una animación de este tipo haciéndola vosotros? ¿De qué orden? Tampoco
puede variar mucho, porque ¿qué es lo que puede ocurrir? Puede ocurrir que tú me pidas algo como esto y resulta que yo tengo el 90% de los modelos virtuales hechos para una producción. Entonces el coste es otro. Porque claro, yo no veo a ICFO como un cliente normal, o como una industria que me llama a mí, yo le hago no sé qué, intento sacar el 25, el 30% de margen económico. No, yo intento ayudar al instituto, quiero estar en los créditos, quiero tener un carnet de ifoniano, como tengo, y pasar por allí. Claro, o sea, estamos en un concepto distinto. Claro, cuando nosotros hablamos de hacer una serie de televisión sobre fotónica, pues vamos a trabajar juntos en intentar vender este proyecto fuera. Fijaros qué cosa tan alucinante. El episodio de... O sea, esta es una serie que es ultra y cada episodio es ultra algo. Pues en ultra fast, si tú vas a ICFO, tienen todos los pasillos divididos en este tipo de cuestiones. Pues en el episodio de ultra fast estamos hablando de conseguir pulsos de luz del nivel de aptosecond. Con esos pulsos de luz de aptosecond vamos a poder fotografiar y hacer y filmar el intercambio de electrones en una reacción química, ¿eh? Claro, entonces, contar todo esto a la audiencia, al mismo tiempo que generas unos materiales de lujo en el instituto, al mismo tiempo que financias unos modelos virtuales y tal, va a ser muy difícil que salgan de las líneas y de los presupuestos de investigación del instituto. Es mejor pensar en una gran producción audiovisual, que ahí sí hay dinero, y hacer que eso baje hacia abajo. No sé si me explico, ¿eh?
Vale, pues vamos a agradecer a José Antonio una vez más por la excelente presentación.
Well, basically just a couple of minutes to talk a little bit. Well, basically first to thank the people that funded this symposium, that the Barcelona Supercomputer Center, also the Catalan and Spanish Chemical Society, and also the Faculty of Pharmacy and Chemistry. Then basically, well, last year also at the end of the symposium, because this symposium started some years ago as try to have a collaboration with some companies and academic researchers. And after the pandemic, we changed a little bit. We changed, first was every 2 years. The last 3 symposiums were 3 years in row. And this is the 3rd year. And basically, after the pandemic, we started 3 years ago with artificial intelligence in chemistry. Last year was quantum computing, and this year is this virtual reality. For the next year, I completely open. I don't know if back to the system what to have every 2 years, or we will continue every year, but I completely open to any idea of about topics. And then if you have any idea, you can talk with me. Already some people, for instance, last Monday, we have a meeting with the external committee, and they say that now you have many experimental groups. Maybe you have to prepare the symposium trying to have a topic that will be interesting for theoreticians and at the same time for the experimentalists. I think that, for instance, the topic that we had this year fulfilled this requirement, but maybe we can keep this idea in mind for the next years. And well, basically, this is all. Thank you all of you for coming. And well, I hope that next year or maybe in 2 years, we will have the next, and all of you will be here. Thank you very much.